The concern regarding building insulation in contact with service entrance cable is valid because it can impede heat dissipation. The suggestion of removing insulation every 10 feet is not necessarily practical or required. According to the note referenced with 310.10, service entrance cable is permitted to be installed in direct contact with thermal insulation if the insulation's thermal resistance, or R value, does not exceed the value specified in Table 310.15b16. Therefore, the proper approach is to determine the R value of the building insulation and compare it to the allowable R value found in Table 310.15b16 of the National Electrical Code. If the insulation's R value is at or below the allowable limit, the service entrance cable installation is compliant and no spacing or insulation removal is necessary. There are additional points to consider. Firstly, service entrance cable typically has a continuous metal sheath, which aids in effective heat dissipation. This sheath's thermal conductivity facilitates heat transfer to the surrounding environment. Secondly, in many situations, the R value of standard building insulation is within the allowable limits for direct contact with service entrance cable. Thirdly, space limitations are often present challenges in apartment buildings, making it difficult to create gaps between the cable and the insulation. If the insulation's R value exceeds the allowable limit, there are alternative solutions to consider. One option is to use a different cable type with a higher current rating that can accommodate the additional heat load. Another option involves providing ventilation or other methods of heat dissipation along the cable's path. In conclusion, rather than removing building insulation, it is essential to verify that the insulation's R value complies with the requirements outlined in 310.10. If the insulation meets these requirements, the service entrance cable can remain in direct contact with the insulation without affecting its safety or operational performance. It is also important to consult local electrical codes and regulations, as they may have specific requirements or interpretations regarding service entrance cable installations and insulation. Proper documentation of the insulation's R value and compliance with the electrical code is also crucial for inspection purposes. Furthermore, ensure that the service entrance cable is properly supported and secured according to the manufacturer's instructions and the electrical code. This helps prevent mechanical stress on the cable and ensures proper heat dissipation. If there is any doubt about the compliance of the installation, it is always best to consult with a qualified electrical engineer or inspector. They can provide expert guidance and ensure that the installation meets all applicable safety and code requirements. Remember that electrical installations should always be performed by qualified and licensed electricians to minimize the risk of electrical hazards. The continuous metal sheath of service entrance cable plays a crucial role in heat dissipation. This metal sheath acts as a thermal conductor, drawing heat away from the conductors within the cable and transferring it to the surrounding environment. This is especially important when the cable is in contact with insulation, as the insulation can act as a thermal barrier, preventing heat from escaping. The effectiveness of the metal sheath in dissipating heat depends on several factors, including the type of metal used, the thickness of the sheath, and the surface area of the sheath that is exposed to the surrounding environment. Generally, copper or aluminum sheaths are preferred due to their high thermal conductivity. The thicker the sheath, the better it can conduct heat away from the conductors. The greater the surface area of the sheath that is exposed to the surrounding environment, the more effectively it can dissipate heat. In situations where the service entrance cable is completely surrounded by insulation, the metal sheath may not be able to dissipate heat effectively enough to prevent overheating. In these cases, it may be necessary to provide additional ventilation or cooling to the cable. This could involve leaving gaps between the cable and the insulation, or installing fans or other cooling devices to circulate air around the cable. It is important to note that the National Electrical Code provides specific requirements for the ampacity of service entrance cable, which takes into account the effects of insulation and other factors on heat dissipation. The ampacity of a cable is the maximum amount of current that it can safely carry without overheating. The NEC provides tables that list the ampacity of different types of cables under different conditions. When installing service entrance cable, it is important to select a cable with an ampacity that is sufficient to carry the expected load. It is also important to follow the NEC requirements for determining the ampacity of cables in certain situations, such as when they are installed in conduit or in close proximity to other cables. By following these guidelines, you can ensure that the service entrance cable is installed safely and will not overheat. The R value of insulation is a measure of its thermal resistance, or its ability to resist the flow of heat. The higher the R value, the better the insulation's ability to resist heat flow. The R value of insulation is typically expressed in units of IO square foot degrees Fahrenheit per British thermal unit, or HRFT 2 degrees F/BTU. The R value of insulation depends on several factors, including the type of material used, its thickness, and its density. Different types of insulation have different R values. For example, fiberglass insulation typically has an R value of around 3.0 to 4.0 per inch of thickness, while spray foam insulation can have an R value of up to 6.5 per inch of thickness. The thicker the insulation, the higher its R value. For example, a 6-inch thick batt of fiberglass insulation will have a higher R value than a 3-inch thick batt of the same material. The denser the insulation, the higher its R value. For example, dense packed cellulose insulation will have a higher R value than loose fill cellulose insulation. The R value of insulation is an important factor to consider when selecting insulation for a building. The higher the R value of the insulation, the better the building will be insulated, and the less energy will be required to heat and cool it. The NEC requires that service entrance cable be installed in accordance with its ampacity rating, which takes into account the effects of insulation on heat dissipation. When service entrance cable is installed in contact with insulation, the insulation can reduce the cable's ability to dissipate heat, which can lead to overheating and potentially a fire hazard. To prevent this, the NEC requires that the ampacity of service entrance cable be determined when it is installed in contact with insulation. The amount of deterring depends on the type of insulation and the ambient temperature. Table 310.15b16 of the NEC provides guidance on the allowable R values for insulation in contact with service entrance cable. If the insulation's R value exceeds the allowable value, the cable's ampacity must be determined. In addition to determining the ampacity of service entrance cable when it is installed in contact with insulation, it is also important to ensure that the cable is properly supported and protected from physical damage. The NEC provides specific requirements for the support and protection of service entrance cable. By following these requirements, you can ensure that the service entrance cable is installed safely and will not overheat. When selecting service entrance cable for an apartment building, it is important to consider the specific needs of the building and the individual apartments. Factors to consider include the size of the apartments, the number of appliances and electrical devices that will be used in each apartment, and the overall electrical load of the building. It is also important to consider the voltage and amperage requirements of the service entrance cable. The voltage must be compatible with the building's electrical system, and the amperage must be sufficient to carry the expected load. In addition to these technical factors, it is also important to consider the cost of the service entrance cable. Service entrance cable can vary in price depending on the type of cable, its size, and its amperage rating. It is important to select a cable that is both affordable and meets the needs of the building. Once you have selected the appropriate service entrance cable, it is important to install it properly. Service entrance cable should always be installed by a qualified electrician. The electrician will ensure that the cable is installed in accordance with the NEC and all local electrical codes. The electrician will also ensure that the cable is properly supported and protected from physical damage. By following these guidelines, you can ensure that the service entrance cable is installed safely and will provide reliable electrical service to the apartment building. Remember, the purpose of electrical codes and regulations is to ensure the safety of people and property. Compliance with these codes is not just a matter of following rules, but a commitment to preventing electrical hazards and protecting lives. Always prioritize safety and consult with qualified professionals when dealing with electrical installations. Understanding the principles of heat transfer is crucial for electrical installations, especially when dealing with insulated cables. Heat transfer occurs through three primary mechanisms: conduction, convection, and radiation. Conduction is the transfer of heat through a material by direct contact. In the case of service entrance cable, heat is generated within the conductors due to the flow of electric current. This heat is then conducted through the conductor material, the insulation surrounding the conductor, and the outer sheath of the cable. The rate of heat conduction depends on the thermal conductivity of the materials involved. Materials with high thermal conductivity, such as copper and aluminum, conduct heat more readily than materials with low thermal conductivity, such as insulation. Convection is the transfer of heat by the movement of fluids, such as air or water. In the case of service entrance cable, heat can be transferred away from the cable by convection if there is air circulating around it. The rate of heat convection depends on the temperature difference between the cable and the surrounding air, as well as the velocity of the airflow. Radiation is the transfer of heat by electromagnetic waves. All objects emit thermal radiation, and the amount of radiation emitted depends on the object's temperature and emissivity. In the case of service entrance cable, heat can be radiated away from the cable if it is exposed to the surrounding environment. The rate of heat radiation depends on the temperature difference between the cable and the surrounding environment, as well as the emissivity of the cable's surface. When service entrance cable is installed in contact with insulation, the insulation acts as a thermal barrier, reducing the rate of heat transfer by all three mechanisms: conduction, convection, and radiation. This can lead to a buildup of heat within the cable, which can potentially cause overheating and a fire hazard. That is why it is important to select service entrance cable with an ampacity rating that is appropriate for the specific installation conditions, taking into account the effects of insulation and other factors on heat dissipation. If the insulation's R value is too high, the cable's ampacity must be derated to compensate for the reduced heat transfer. In addition to selecting the appropriate cable and derating its ampacity, it is also important to ensure that the cable is properly installed and supported. The cable should be installed in a way that allows for adequate air circulation around it, and it should be supported in a way that prevents it from being damaged. By following these guidelines, you can ensure that service entrance cable is installed safely and will provide reliable electrical service. Different types of service entrance cable are available, each with its own advantages and disadvantages. The most common types of service entrance cable are Type SE and Type Use. Type SE cable is a general-purpose cable that is suitable for use in both wet and dry locations. It consists of insulated conductors surrounded by a moisture-resistant jacket. Type Use cable is a cable that is specifically designed for underground use. It consists of insulated conductors surrounded by a waterproof jacket. When selecting service entrance cable, it is important to consider the specific needs of the installation. Type SE cable is generally less expensive than Type Use cable, but it is not suitable for underground use. Type Use cable is more expensive than Type SE cable, but it is suitable for both underground and above-ground use. In addition to these two types of service entrance cable, there are also a number of specialty cables available. These cables are designed for specific applications, such as use in hazardous locations or in high-temperature environments. When selecting service entrance cable, it is important to consult with a qualified electrician to determine the best type of cable for the specific installation. Always consult with a qualified electrician to ensure that the service entrance cable is installed safely and in accordance with all applicable codes and regulations. Understanding the NEC requirements for service entrance cable is essential for ensuring a safe and compliant electrical installation. The NEC provides detailed guidelines on the selection, installation, and protection of service entrance cable. These guidelines cover a wide range of topics, including ampacity, derating, support, protection from physical damage, and grounding. It is important to be familiar with these requirements before installing service entrance cable. The NEC is updated every 3 years, so it is important to use the latest version of the code. The NEC is available from the National Fire Protection Association. The NEC is a complex document, and it can be difficult to understand all of the requirements. If you have any questions about the NEC requirements for service entrance cable, it is best to consult with a qualified electrician.